Hi everyone, and welcome to EasyEDA. In the last lesson, we finished defining the functions in our program and went through how to create each of them. Now, we're moving on to a brand new part, web page development. In this session, we're going to learn how to use a web page as a control interface for our Robotdog and how to design one by ourselves from scratch. Before we dive into the hands-on part, I recommend getting a basic understanding of HTML, CSS, and JavaScript, because what we are trying to do here is to make a web interface talk to an end program, basically turning a web page into a remote control for our Robotdog. So why use a web page? Well, the big advantage is that we don't need to develop a separate app, and we don't need to worry about compatibility with Android, iOS, Windows, or Linux. As long as your device has a browser, even feature a phone, a smartwatch, or an e-ink display, it can control the robot. This lesson is divided into 4 main parts: HTML and CSS, JavaScript, integration with the C program, wrap-up. Before writing any code, we suggest installing an HTML preview plugin and VS Code. This way, we can see our web page layout instantly as we code, super helpful for debugging. So open VS Code, go to the Extensions tab on the left and search for HTML Preview. Some plugs might show deprecated. Just skip those and choose the one that's still actively maintained. Once it's installed, the shortcut to the preview page is hold Ctrl and K and press V. And there you go, live preview. Let's start coding. First, create a new folder in your workspace called data. This is where we'll store all the web page files. Inside that, make a new HTML file that's called index.html. Even if you don't have a template, no worries. We can write everything from scratch. First, declare the encoding as UTF-8 and set a page title, say EDA Robot. The title is what you will see at the top of your browser tab. Then, add a style tag, that's where your CSS. Add a script tag, that's where your JavaScript will go. And finally, add a body tag, that's where all your visible content will live. Let's write some basic styles. First, set the margin and padding of the whole page to 0. Pick a clearer looking font, you can use your favorite here. Next, we'll add a div to center our content. Give the div a class name like a container, and the CSS will set it to be centered. Get it a fixed width like 800 pixels. Set left and right margins to auto, top and bottom margin to 0, and add some padding like 20 pixels. And use text align center to center the text inside. Now inside the center div, you can start adding your page content. Let's add a big heading, something like Robot Control Interface. You can add subheadings, instructions, it's totally up to your design. In this project, we're focusing controlling 180-degree servos, so we won't include things like servo collaboration here. Once you're done, hit Ctrl and V and K to preview the page. You should see everything centered and styled as expected. When building your page, keep everything inside that centered div, otherwise new content might appear off to the side, which look messy. For example, if you're adding a button, make sure it's inside the same div. Let's go ahead and add a button for testing interactions. Inside the container div, add a button element. Let's give the button a function. When clicked it should go to a new page called control.html. And now we style the button. Fix width and height. Add some spacing around it. Use a light or dark blue background. White font color. Remove default borders. And round corners and shadows for a 3D look. Just remember, double check your file path. If a link doesn't work, it's probably because the file name or path is wrong. Maybe add a transition so that on hover, the color brightness slightly, and the shadow depends. Let's go ahead and create the control.html page. Copy the structure from index.html and then tweak it for the control layout. On this page, we'll break it into different sections. Top, battery voltage and power info. Middle, motion control buttons. Bottom, functions buttons like raise hand, lie down, auto mode, etc. Use separate divs for each area and assign them class names or IDs for later JavaScript control. Up, forward, down, backward, left, right, raise left, raise right hand, lie down, sit, auto mode, recovery mode. Same as before, make all your buttons look consistent. Set width and height, add margins, set background color, font color, rounded corners, shadow, hover effect, click animation. For colors, try soft RGB values like light yellow or sky blue for a clean feel. You can use color names or RGB codes. If you're using VS Code, install a color picker plugin. It shows color previews right in the editor. Names should match your command definitions in the code so everything connects correctly. We also need a new section for networking. This includes just two things, displaying time and weather. So let's make a separate div for this too. Be careful in div nesting. If something looks off, you may have forgotten or closed a div or added too many. If a section doesn't have label, users might not know what it's for. So add headings like networking, expressions, or motion controls above each block. As for font color, adjust it based on your background, white or light gray, so everything looks unified. By this point, the layout is mostly done. Now let's move on to the JavaScript part. First, let's fix and double check all our command paths. They must match the ones used in the C program or the system won't recognize them. Next, we'll create a send command function. This function will use fetch to send commands to the correct path, like forward or left. Then write another function to get device status, like battery voltage, and update the HTML elements with that data. Add an auto refresh function to update the data every second. Once these are ready, we can trigger them when the page loads, like start refreshing the moment the user opens the page. Watch out, your IDs in HTML must match the ones you use in JavaScript. For example, if your HTML has ID equals your voltage, you must use the exact ID in your script or it won't work. Now let's also finish the settings page. This one is way simpler than the control page. We'll just create a form that uses this post message to submit Wi-Fi credentials and other info to the server. In the form, an input fields like Wi-Fi name, Wi-Fi password, weather API, city PNE. Give each input in a class like input style and write CSS for that class. You can even reuse the button styles from the control page from visual consistency. Don't forget to add a submit button using button. Label it save or submit settings whenever you like. Preview the setting page. The inputs are centered with rounded corners and matching background. The buttons look consistent. Overall, it's clean and minimal. So now, front-end development is done. Alright, let's talk about integrating the C code. This part can be tricky and it's very easy to mess up, especially with the command paths. Earlier, we defined all these commands in a web page, like front, left, etc. Now we need to listen for those exact paths in the C program. If the web page sends front, but your code listens for move forward, nothing will happen. The ESP8266 won't even receive the request. So the path was matched exactly. Let's open the VS Code, go to function handle Wi-Fi configure, and start configuring. Step 1 is to set up the server to listen for a path. Let's start with forward command. If the web stands front, you listen for front. The request method must match too. If the web sends the get request, you must listen for get. If it's a post, then it's a post. These handlers should be async so they don't block the main loop. Once the command is processed, send a status response back, usually HTTP 2000 for success. Other codes include 404 not found, 403 forbidden, 502 server error. Back to our example, when front is triggered, respond with 200K and send something like forward activated. Now that command is complete. We'll add more: left, right, back, stop, sit, sleep, free mode, recovery mode, etc. The structure is mostly the same, so you can copy paste and just change the passing state. Pro tip, open the web page and code side by side. Check each command, make sure the path matches, no typos, no missing routes. For free mode and similar commands, we use a bool variable, not an action state number because we defined it as bool earlier. For battery status, also listen for a path, get a voltage, cover it with a string, and send it back to the web. No need to set a state, just read and send the data. Next is the emoji control, like angry, awkward, sad, sleep, etc. Same as before, listen for path, assign to each an emoji state. You can use a number starting from 1, keep 0 as the default or no emoji to avoid accidents. Here, we're not returning any data to the web, so just reply with a simple OK or success. Finally, the time and weather functions. These come from the settings from sent via post request to something like connect. The post data will include SSID, password, API, and city name. Make sure the name will include SSID, the name field match the variables names in your code. If the HTML says name equal to SSID, your C code must read SSID. To check if it's working, you can print the received data to the serial monitor for debugging. So overall, the C integration part requires careful path matching. Correct request types and make sure all variable names are consistent. If anything's wrong, debugging gets super messy, so double check everything. When we visit the ESP's IP address, it defaults to loading the root path, which typically corresponds to the home page. In the C program, we need to set up a route handler to load that file from SPIFFs and serve it to the browser. The process is open the file in read mode, read it byte by byte or as a string, and return it over HTTP. If the file isn't found, we return it a 404 error, not because the server is down, but because this file literally doesn't exist. Beside the home page, we also need to serve the control page /control and setting page /setting. Method is the same. Load the file from SPIFFs and send it back. The file names may differ depending how you've named it. For example, if you use controller.html, be sure to read that exact file. If your project uses a 360-degree servo, there may also be a motor calibration page. That's only required for some versions. 180-degree servo modes don't need this. In this section, we've covered structure and function on the web control interface, how the script sends requests to the backend, how the C program listens to web routes and receives data, how to save configuration data into SPIFFs, how to load web content from SPIFs and send it to the browser, how to handle front-end status update based on Wi-Fi connection status. At this point, you should be able to design your own web control panel, and even get creative by embedding mini games like Snakes or Space Shooter to interact with your device. You can also further improve your request handlers or build a small web app on top of this system.